Good morning, everybody. Myself, Acharya Vishvendra. Today, we'll discuss NCERT line to line with the chapter oscillations. So, let's start with the first question. It says that position of a particle executing SHM is given by x is equal to 10 cos pi t plus pi by 3 centimeter. So, first question is initial position. Initial means t is equal to 0. So, if t is 0, then x is 10 cos pi by 3. Cos pi by 3 is 1 by 2. So this is 5 centimeters. So first will be correct. Next is angular frequency is. So the coefficient of t is the angular frequency. If we compare with the standard equation equals omega t. So angular frequency here is omega, which is pi. So first will be correct. Next question is time period. So time period is 2 pi by omega, which is 2 pi by pi, which is 2 seconds. So first will be correct. Next is frequency. Frequency is 1 upon t. So 1 by 2 hertz. Next is initial velocity. So for finding velocity, we have to differentiate x. So velocity here is dx by dt, which will be 10. Differentiation of cos is minus sine pi t plus pi by 4. And pi here will be multiplied as this is not a simple function. So if t is equal to 0, then we have minus 10 pi, and it will be sine pi by 3, which is root 3 by 2. So we have minus 5 root 3 pi. So initial velocity is minus 5 root 3 pi. So here just make it minus. So first option will be correct here. Next is initial acceleration. So for finding acceleration, you have to differentiate velocity. So as velocity here is minus 10 sine pi t plus pi by 3 into pi. So acceleration will be dv by dt, which will be minus 10 pi, and differentiation of sine is cos pi t plus pi by 3 into pi, so it will be pi square. T is equal to 0, so this will reduce to cos pi by 3, which is 1 by 2, so it will be minus 5 pi square. So second will be correct here. Next is distance traveled by particle in one complete oscillation. So this is 4a. So that will be 4 into 10 centimeter, which will be 40 centimeter. Next is a force F is equal to minus kx, X on a particle. Constraint to move along x-axis. At t is equal to 0, the particle is at x is equal to a and is stationary. A graphical representation of the force is represented as, so here one thing is missed, k is positive, otherwise particle will not come back to the origin itself. So f is proportional to minus x, so graph will be a straight line with negative slope. So first will be correct over here. Next is resulting motion of the particle is. So it represents an SHM which is periodic as well as oscillatory. So all of these will be correct. So fourth will be the best option. Next is time period of motion. So time period is force is equal to minus kx. Force is ma. So ma is equal to minus of kx. So here next is graphical variation between t and k. So t proportional to 1 by root k, so the graph will be as a rectangular shape like rectangular hyperbola. So second is correct over here. Next is graph between t and 1 by root k. So here t is proportional to 1 by root k, and let's say 1 by root k is equal to x. So graph will be a straight line as given by curve 1. Next is resultant force on a particle in shm-ncert, constant or time dependent. So it is obviously time dependent because it depends on x, and which depends on time. Next is simple harmonic motion is an example of, so it's a linear harmonic oscillator because force is proportional to the linear power, that is first power of the position. So first is correct over here. Next is initially, here we are being given two springs which are connected to a block of mass m, and then time period of motion. So you can see these two springs are in parallel because the magnitude of elongation is same in both, and we know that springs are in parallel, then their equivalent spring constant is k1 plus k2, so that will be 2k plus 3k, that will be equal to 5k. Now we have to find the time period of motion, so it is 2 pi root m by k equivalent, which is 2 pi root m by 5k. So first is correct. Next is frequency of motion. So frequency is 1 by time. So it will be 1 by 2k, 1 by 2 pi, sorry, 5m upon 1 upon 2 pi root m into 5k. So this is first will be correct. Next is angular frequency of motion is, so angular frequency will be omega, which is root 5k by m, which is given by option 1. Next is equation of shm is, so obviously initially particle is at origin, so it corresponds to, so here particle is initially at x is equal to a, so at t is equal to 0, x should be equal to a, which is only possible in option 2, so second is correct. Next, velocity is given by, you differentiate this, so that will be a minus of sine root 5 kt by m, and then we have to multiply it with root 5k by m also. So here there is some error in it, so just multiply it with root 5k by m, or we can say that fourth is correct here, as none of the option is matching. Next is a particle executing shm has only kinetic energy, only potential energy, both. So both energy it possesses. Next is a particle is moving along x-axis as given by this equation. Kinetic energy of the particle is, so you find velocity as dx by dt, which is a omega cos omega t plus phi. Now kinetic energy is half mv square, which is half m a square omega square cos square omega t plus phi. So second is correct over here. Next is potential energy of the particle is, so potential energy is given by, potential energy is given by u naught plus half kx square, so it will correspond to the first option, and total mechanical energy is the sum of both, so it will be equivalent to 1.